Hey class, welcome to Husky Math. We are continuing from question number 6. In previous video, it was up to question number 5. So here the question is, prove that tan inverse of 3 over 4 plus tan inverse of 3 over 5 minus tan inverse of 8 over 19 equals to pi over 4. So let us start from left hand side. So in the left hand side, I have tan inverse of 3 over 4 plus tan inverse of 3 over 5 minus tan inverse of 8 over 19. So first we will add these two terms. So it will be, so before adding, let's multiply this 3 by 4 and 3 by 5. So it will be 9 by 20, which is less than 1. So that means we have to use the formula without pi. So it will be tan inverse of x plus y, that is 3 over 4 plus 3 over 5 whole divided by 1 minus 3 over 4 times 3 over 5 minus tan inverse of 8 over 19. This equals to tan inverse of, so the LCM will be here 20. So 5 3s are 15 plus 4 3s are 12 times 20 over 20 minus 9 minus tan inverse of 8 over 19. So here 20 and 20 gets cancelled. So it will be tan inverse of 27 over 11 minus tan inverse of 18, tan inverse of 8 over 19. So if you have noticed, I have written one formula here, that is tan inverse of x minus tan inverse of y can be written as tan inverse of x minus y over 1 plus x times y. And this formula can be used only if x times y is greater than minus 1. So let's multiply this x and y. So if I multiply 27 over 11 times 8 over 19, this will be obviously greater than minus 1 since this is positive. So we can use that relation here. So it will be tan inverse of x minus y, that is 27 over 11 minus 8 over 19 whole divided by 1 plus 27 over 11 times 8 over 19. Let's simplify this further. So tan inverse of, so if I take the LCM of 11 and 19, then it will be 209, and in numerator it will be 513 minus 88 times 209 over 209 plus 216. So it will be equal to tan inverse of 209 gets cancelled. So here it will be 425 over, if you add 209 and 216, it will also be 425. So it will be tan inverse of 1, which can be written as tan inverse of tan 45 degree. Hence my left hand side is pi by 4. So in the right hand side also there is pi by 4. So the proof is done. So equals to, I can write right hand side, hence proved. Next question number 7. Prove that tan inverse of 1 over 2 plus tan inverse of 2 over 11 equals to tan inverse of 3 over 4. So here we will be using the same formula which we have used in the previous videos also. Okay, so first let us check this 1 over 2 over into 2 over 11 will be 1 by 2 into 2 by 11 will be 1 over 11, which is less than 1. So we can use the formula, that is tan inverse of x plus y over 1 minus x times y. So in fact this is my left hand side. So it will be equal to tan inverse of, so the LCM will be 22. So 11 plus 4 times 22 over 22 minus 2. So 22 gets cancelled, so it will be tan inverse of 15 over 20. So this equals to tan inverse of 3 by 4, which is same in the right hand side, hence proved. Question number 8, we have to prove that 2 tan inverse of 1 over 2 plus tan inverse of 1 over 7 equals to tan inverse of 31 over 17. If you can solve this, just pause the video and try to solve by yourself. So here on the left hand side, we have 2 tan inverse of 1 over 2. So it can be written as tan inverse of 1 over 2 plus tan inverse of 1 over 2 plus tan inverse of 1 over 7. So let's add the first two terms. So 1 by 2 into 1 by 2 is 1 by 4, which is obviously less than 1. So we can use that formula, that is tan inverse of x plus y over 1 minus xy plus tan inverse of 1 over 7. So it will be equal to tan inverse of 2 by 2 times 4 by 3 plus tan inverse of 7. So here it will be tan inverse of 4 over 3 plus tan inverse of 1 over 7. So if I multiply x and y again, it will be less than 1. So it will be equal to tan inverse of x plus y over 1 minus x times y. So it will be equal to tan inverse of the LCM of 3 and 7 is 21. So 7 4s are 28 plus 3 times 21 over 21 minus 4. So it will be tan inverse of 31 over 17, which is on the right hand side, hence proved. So question number 9, I'll leave you as a homework. Okay, so do this by yourself. You just need to use the same formula, okay, and you have to get the value pi by 4. So question number 10, solve tan inverse of 2x plus tan inverse of 3x equals to pi over 4. To solve means to find the value of x. So let's start using the formula. So here it will be tan inverse of 2x plus 3x over 1 minus 2x into 3x equals to pi over 4. So it will be 5x by 1 minus 6x square equals to tan of pi over 4. So operating both side by tan equals to 5x by 1 minus 6x square equals to tan pi by 4 is 1. So it will be 5x equals to 1 minus 6x square. So it will imply 6x square plus 5x minus 1 equals to 0. So let's split the middle term. So it will be 6x minus x minus 1 equals to 0. So it implies 6x x plus 1 minus x plus 1 equals to 0. So this implies x plus 1 times 6x minus 1 equals to 0. So either x equals to minus 1 or x equals to 1 over 6. So these are the answers for question number 10. Next question number 11, we have find the value of tan inverse of 2 cos 2 sine inverse of 1 over 2. So here we will have tan inverse of 2 cos, and here it will be 2 sine inverse of, so instead of half I can write
sine 30, that is sine pi by 6. Since pi by 6 is in the principal value range, so it will be tan inverse of 2 cos 2. Sine inverse of sine pi by 6 is simply pi by 6. So it will be equal to tan inverse of 2 cos of pi by 3. So it will be equal to tan inverse of 2 cos 60 means 1 by 2. So it will be tan inverse of 1, and 1 can be written as tan inverse of tan pi over 4. Hence my answer is pi by 4. Find the value of cosec 2 cot inverse of 5 plus cos inverse of 4 over 5. So here let me consider this cot inverse of 5 as theta and this cos inverse of 4 over 5 as phi. So let this be theta and let this be phi. Okay, then my question will be cosec of 2 theta plus phi. So here let theta equals to cot inverse of 5. This implies cot theta equals to 5. So this implies tan theta equals to 1 over 5 because cot and tan are inverse of each other. So now let me draw a right angle triangle, and if this angle is theta, then tan 1 over 5 equals to perpendicular by base. So my perpendicular is 1 and my base will be 5. So let's find the hypotenuse. So by Pythagoras theorem we have h square equals to p square plus b square. So this implies h square equals to 1 square plus 5 square. So this implies h will be square root of 1 plus 25, which will be equals to root over 26. So here the hypotenuse is root over 26. So since we know all the 3 sides of a right angle triangle, now we can find the value of sine and cos. Therefore sine theta will be perpendicular by hypotenuse, so it will be 1 over root 26, and cos theta will be base over hypotenuse, so it will be 5 over root 26. Now let us try to find the value of 2 theta, okay, because here if you see we have 2 theta here in the question, cosec 2 theta, okay. I will start by sine 2 theta. So the value of sine 2 theta is 2 sine theta cos theta. So it will be equals to 2 into sine theta is 1 over root 26 and cos theta is 5 over root 26. So it will be 10 over 26 and it will be 5 over 13. So the value of sine 2 theta is 5 over 13. Let us also find the value of cos 2 theta. So cos 2 theta equals to, the formula for cos 2 theta is cos square theta minus sine square theta. So it will be equal to 5 over root 26 whole square minus 1 over root 26 whole square. So it will be 25 over 26 minus 1 over 26. So on simplifying we will get 24 over 26, which will be equal to 12 by 13. So using the value of theta, we have found the value of sine 2 theta and cos 2 theta. So I have simply written the value of sine 2 theta and cos 2 theta. Now let us try to find the value of phi, okay. Let us make another right angle triangle. let this angle be phi. We have considered phi as cos inverse of 4 over 5. So it will be equal to cos phi equals to 4 over 5. So now looking at this relation, we can write the value of base and hypotenuse. The base will be 4 here and hypotenuse will be 5 here. By using Pythagoras theorem, we can calculate the value of perpendicular, so it will come 3. Okay, so I am not doing that here. So you just try to find the value by yourself. The perpendicular will be 3. Okay, so now let us find the value of sine. So therefore sine phi will be perpendicular over hypotenuse, so it will be 3 over 5. Okay, so that means the value of sine phi and cos phi we have got. So my question was cosec 2 theta plus phi. So cosec is the inverse of sine, so I can write this as 1 over sine 2 theta plus phi, and this is in the form of sine a plus b, so we will use that formula. So it will be 1 by sine a cos b plus cos a sine b. So it will be equal to 1 over, so sine 2 theta is 5 by 13, cos phi is 4 over 5, plus cos 2 theta is 12 by 13, and sine phi is 3 over 5. So on simplifying, we will get 1 by 20 over 65 plus 36 over 65. So it will be 1 by 20 plus 36 over 65. So it will be equals to 65 over 56. So this is the answer for this. If sine inverse of x equals to tan inverse of y, then show that 1 over x square minus 1 over y square equals to 1. So let us consider sine inverse of x equals to tan inverse of y equals to theta. So that means sine inverse x is theta and tan inverse of y is also theta. So from here it will be x equals to sine theta and y equals to tan theta. So I have to show that 1 over x square minus 1 over y square equals to 1. So let me write the left hand side. So here the left hand side is 1 over x square minus 1 over y square. So it will be equal to 1 over, see, x is sine theta, so it will be sine square theta, minus 1 over y is tan theta, so it will be tan square theta. So 1 over sine square theta is cos x square theta, minus 1 over tan square theta is cot square theta. So it will be equals to 1, because this is the trigonometric identity. So which is same on the right hand side, hence proved. Next question number 14. If tan inverse of x plus tan inverse of y plus tan inverse of z equals to pi over 2, then we have to show that xy plus yz plus zx equals to 1. From here we can write tan inverse of x plus tan inverse of y equals to pi over 2 minus tan inverse of z. So the formula for tan inverse x plus tan inverse y is tan inverse of x plus y over 1 minus xy equals to pi by 2 minus tan inverse of z. So operating both sides by tan, we will get x plus y by 1 minus xy equals to tan of pi by 2 minus tan inverse of z. Now considering this as angle theta, so we can write tan 90 minus theta is cot theta. So it will be x plus y by 1 minus xy equals to, so this will be cot theta, and theta is tan inverse of z. So this implies x plus y over 1 minus xy equals to cot of, see, tan inverse of z can be written as cot inverse of 1 over z. Hence, x plus y over 1 minus xy equals to 1 over z. Let's cross multiply, so we will get zx plus yz equals to 1 minus xy. So let's bring minus xy here, so it will be xy plus yz plus zx equals to 1. So this was the relation which we had to prove. If tan inverse of x plus tan inverse of y plus tan inverse of z equals to pi over 2 and x plus y plus z equals to root over 3, then so that x equals to y equals to z. So in previous question we had proof if tan inverse of x plus tan inverse of y plus tan inverse of z equals to pi over 2, then we had proved one relation, that was xy plus yz plus zx equals to 1. So up to here you have to do like question number 14 only. Okay, so now here the question has given another thing, that is x plus y plus z equals to root over 3. So we will start from here. Okay, so x plus y plus z equals to root over 3. So if I square both sides, then it will be x plus y plus z whole square equals to 3. The formula for x plus y plus z whole square is x square plus y square plus z square plus 2 times xy plus yz plus zx equals to 3. Now here with 3, I can write 3 as 3 times 1. So in the next step, in place of this 1, I will be writing xy plus yz plus zx. So it will be x square plus y square plus z square plus 2 xy plus yz plus zx equals to 3 times xy plus yz plus zx. So here it will be x square plus y square plus z square plus 2 times xy plus yz plus zx, and it will be minus 3 times xy plus yz plus zx equals to 0. Now since these are both like terms, so we can subtract it directly. So it will be x square plus y square plus z square minus xy plus yz plus zx equals to 0. Now let's multiply both sides by 2, then it will be 2x square plus 2y square plus 2z square minus 2xy, let me open the bracket also, then it will be minus 2yz minus 2zx equals to 0. Now I will be splitting this 2x square 2y square plus 2z square into x square plus y square plus y square plus z square plus z square. Okay, so let me write 1x square here, and after that let me write minus 2xy here, and let me write 1y square here. So another y square will be here, minus 2yz plus z square plus z square minus 2zx plus x square equals to 0. See, I'm just arranging all these terms. Okay, so this 2x square is x square plus x square here, and y square plus y square is 2y square, and z square plus z square is 2z square. Okay, now this particular expression can be written as x minus y whole square. Similarly, the next 3 terms can be collectively written as y minus z whole square plus z minus x whole square equals to 0. Now in the left hand side, this particular term x minus y whole square is a positive, because anything square is always positive. So this is also positive, so this is also positive. And if all the positive values are getting added and the total sum is 0, that means these individual terms are themselves 0. So therefore we can write x minus y whole square equals to 0, y minus z whole square equals to 0, and z minus x whole square equals to 0. So from here we will get x equals to y, and from here we will get y equals to z, and from here we will get z equals to x. So finally we will get x equals to y equals to z. So the question was asking to prove that x, y and z are equal. So this was question number 15. Okay, question number 16 we have. This is the last question of this video. So if sine inverse of x plus sine inverse of y plus sine inverse of z equals to pi, then show that x times root over 1 minus x square plus y root over 1 minus y square plus z 1 root over 1 minus z square equals to 2 times x into y into z. Okay, so here let us consider this sine inverse x as one angle, sine inverse y as another angle, and sine inverse z as another angle. So let sine inverse of x equals to a, sine inverse of y equals to b, and sine inverse z equals to c. So from here x equals to sine a, from here y equals to sine b, and from here z equals to sine c, and a plus b plus c equals to pi. That was given. On the left hand side, x times 1 minus x square plus y times 1 minus y square plus z times 1 minus z square. It will be equal to, so x means sine a root over 1 minus sine square a, plus y means sine b, so it will be sine b into 1 minus sine square b, plus z means sine c, so square root of 1 minus sine square c. This is the formula of cos a, so it will be sine a into cos a. Similarly, it will be sine b into cos b plus sine c into cos c. So let us multiply and divide by 2. So it will be then 1 by 2, 2 sine a cos a plus 2 sine b cos b plus 2 sine c cos c. So this will be equal to 1 by 2, 2 sine a cos a. This is in the form of sine 2 theta. So it is sine 2a. Similarly, this will be sine 2b plus, let me write this term as it is, 2 sine c cos c. Okay, so now here this is in the form of sine theta plus sine phi. So for that I'll be using the formula which I have written already here. Okay, so it will be equal to half 2 sine theta plus phi by 2 cos theta minus phi over 2 plus 2 sine c cos c. So this equals to half 2 sine a plus b cos a minus b plus 2 sine c cos c. So now in the next step, I will be replacing this a plus b as pi minus c, because a plus b plus c equals to pi here, and this particular c as pi minus a plus b. Okay, so we will have half 2 times sine pi minus c cos a minus b plus 2 sine c cos, in place of c I will write pi minus a plus b. So it will be equal to half 2 sine pi minus theta is sine theta only plus 2 sine c cos pi minus theta is minus cos theta. So we can take out 2 sine c and 2 sine c as common, so we will have 2 sine c over 2 cos a minus b minus cos a plus b. So now here this is in the form of cos theta minus cos phi. So I'll be using this relation cos theta minus cos phi here. So it will be, so here 2 and 2 get cancelled, so it will be only sine c. So here it will be 2 sine theta plus phi, that is theta plus phi over 2 sine phi minus theta, that is phi minus theta will be like this. So here minus b plus b get cancelled, plus a minus a got cancelled. So it will be sine c into 2 sine a plus a by 2 is sine a, and sine b plus b by 2 is sine b. So we will have 2 sine a sine b into sine c. But this sine a, sine b and sine c are x, y, z. So we will have 2 into x into y into z, which is equals to right hand side. Hence proved. Okay, so this was the last question for this video. We will be doing more exercises in the next video, and I think that will be the final video. So keep practicing. See you soon. Bye bye. Take care.